Good morning, everyone. My name is Dave Lello. I'm the founder of ETHOS Energy in South Africa, and I'm glad to be able to present at Ethos this year. I'm going to explain this morning a concept that we've been working on, which is called the FabStove gasifier engine. It allows an open source design kit, which is the engine of the stove, to be built into different frames, and I will explain that this morning. The first slide shows 4 different stoves. There's a tabletop stove, a tripod, and 2 different floor standing stoves, one with a brick frame and one with a steel frame. And although these stoves look very different and serve different applications, they all have one thing in common. They use a common stove engine or a common gasifier kit with the same components for the combustion portion of the stove. To explain a little further, you will see that on the right-hand side there is a tabletop frame that's been built, and next to it are the gasifier components. This is an FA-TLUD, so what it has is a fan at the bottom. It has a gasification fire chamber with primary and secondary combustion and the forced airflow through those holes. And then lastly, it has a cooktop for the heat exiting from the gasifier to then be dispersed to the pot above it. How did we get to this? Well, we got to this because we had built a stove, a complete stove, and it is now available in the US market. But the frame of this stove makes up more than half of the cost of the stove. It looks good, it operates well, but this stove is unaffordable for African countries, and in fact importing a frame and paying import duties and all of those kind of things is rather silly. So we looked at this and we said, well, if we can actually achieve a guaranteed performance between the stove components, why not actually produce the stove frame locally? So that allows us to allow artisans to manufacture the frame specific to their needs. As long as the dimensions are correct, we can then drop in a engine kit. That engine kit ships flat and they actually assemble it themselves. And by putting the kit together with the frame, we actually create a localized gasifier stove. Importantly, that stove is now 40% less expensive than the fully manufactured and fully imported stove. So let me explain to you so you understand what we've done, and then we can discuss how that works out. The first part of the gasifier engine is a canister, a steel canister with a wooden frame, a wooden handle, and it has 2 parts to it. There's an outer body with two walls, and then there's a fire chamber which drops into it and is located with 3 screws, and together they make up the gasifier. They're assembled from 8 pre-cut parts, so we pre-cut them, we pre-drill the holes, and they just need to be rolled and put together in the local market. By creating a replaceable fire chamber, we can now extend the life of the whole gasifier by a $3 or $4 replacement of the fire chamber when it is burnt out. And so this obviously reduces the cost of ownership. The next part of the stove is the cooktop. The cooktop sits on top of the gasifier. Our gasifiers are allowed to be taken out and put in for loading and unloading. So this portion is dropped into the frame and remains in the frame. And you will see that it has an extension ring or tube. It has a cup. That cup is made from stainless steel. It helps reflect heat from pot down and improve heat retention. And then it has on top of it a little ring, a pot rest, and that pot rest fits onto a rim around there so that it doesn't move around. The pot rest can be adapted. So you'll see there we have got two examples. There's a pot rest for a flat pot, and there's a pot rest with a slightly deeper rim for heat retention and for a round bottom pot that is available. Those aluminium pots are available in the local African markets and locally made. So the same stove is now able to be used by just replacing the pot rest ring. So I'm going to now explain the detail of how we got to this pot rest design. We took our original stove to the Institute of Thermal Engineering in Graz, to Professor Robert Schala, and he immediately told us that we did not have enough retention time from the time of the secondary flame to the pot. So you'll see on the left of the gas retention time on the slide that there's a very short period of time from the time the flame forms to the time it hits the pot. This is too short. There's still a lot of CO in the gas, and as a result, once it hits the pot, it stops combusting and then releases CO, which obviously reduces the efficiency and increases emissions. By putting a tube on above the gasifier, you can see on the right-hand side that we improve the retention time. You will see on the left in the gas temperature is lower once it hits the pot, but it's still above 700. And we're able to now get a more even flame. So we'll see now that between the two, the heat hitting the bottom of the pot now is a lot more even. Those little 4 marks are where the pot rest is. Those can be improved, but we now don't have hot spots on the bottom of the pot. A lot of the pots in the African markets have thin bottoms, so this would affect the burning of the food in the pot. The effect of this is that we were able to drop the CO emissions by a factor of 10, and with a very small drop in the efficiency of the stove. We believe that with more testing we can raise that efficiency back up to 37-38%. In terms of best-in-class performance, you will see that against the benchmark of all the other stoves, the CO emissions per megajoule delivered into the pot, we're now equal to the performance of an LPG stove. So by a simple extension tube, we've now been able to make a wood biomass stove as efficient from an emission point of view as a gas stove. Portion of a gasifier engine is the fan that actually generates the pressure that blows the air through the fire chamber. We have split this into 2 little boxes. The box on the left is the fan box, which fits into the frame. The fan varies in speed from 2,000 to 6,000 RPM, allowing us to turn down the fan speed and lower the primary combustion. On the right-hand side, you will see a second box. That second box is a control box with a battery in it, with some buttons to control the speed of the fan, check the battery level, and it is connected to the stove with a small cable. The battery is rechargeable from a USB cable, and in fact we can control 2 of the fans with one control box. So some of the designs you saw previously are now able to be controlled with one control box. So that, in summary, is our engine. It consists of the cooktop, the gasifier, and the fan box, and is available as a kit to be built into frames. What does this do? Well, this allows us to get verifiable results. Every unit that we sell comes with a serial number and a materials warranty, and the local assembly partner will now build a frame and drop the kit into it, and that will allow us now to do flexible implementation with projects with various frames that are needed for the local market, but a consistent performance from a combustion. What is planned? Well, we are now planning, once we have got the engine in place, our little control box can now be made intelligent. It will monitor the fan speed and the temperature in the gasifier, record this on a time basis, and can share this information via an IoT platform so that integrators that want to use carbon credits or PayGo are able to now get a geographical map via a web platform of where their stoves are and how they're performing and what CO savings have been done. This will be delivered by June of this year. By just changing the little box and adding a GSM chip or a Bluetooth module to it, we can now track each stove in the field. So what is our intention with the engine concept? Well, one, we'd like to create a website called FabStove.org where we will share all of the research that we've done in terms of the cooktops, the frames that are available. We'll allow people to upload their own frame designs. All of these are open source. The CAD drawings are there, so people can take a basic design and adapt it. And this will be freely available. We will also called FabStove.com. That website will be a B2B website. It'll be there to purchase gasifier kits from us. It'll also allow you to work with us to implement the intelligent platform with an intelligent controller box and some software. And this website is really for us to talk to project implementers to be able to run and operate their pellet sales better and be able to provide a great stove at a great price. So how do we work together? Well, first of all, we'd like you to give us feedback. We think this is a new idea. We think that it's an innovative idea, and we think it's going to help improve the adoption of stoves in the market. Secondly, we would like people to contribute. Lastly, we think this idea could be transferred to things like gasifiers that use wood, logs, and chips. We can help you because we believe that this helps you focus on the application and not on the stove design. The stove kits are available. We provide training on how to build the kit and adapt it to a frame. And because the stoves are tested and certified, they will now easily link into carbon projects that are approved by the United Nations. Thank you very much for your time. My contact is available on the bottom. You will also see Paul Anderson, who I've worked closely with, Dr. FA-TLUD, and he has information for you if you need to and how to get hold of me. Thank you very much.